Good afternoon, everybody. We're just waiting for folks to come in, and we're going to start our roundtable here in just a couple minutes. So let's uh, let's let everybody get out of the waiting room and into the session. We'll get started. All right. I know we'll have some more folks coming in as we get started, but we got a lot of material to cover today, and some great folks to present some good information. So I'm Dave Carter, along with Chris Roper. We're the regional directors for Flower Hill Institute, coordinating the technical assistance program for USDA meat and poultry processing. And this is not our usual location. Chris and I have actually been down in Puerto Rico. We're in Virgin Islands today, St. Thomas, working with some small producers and processors here. Just went through an abattoir that is looking to refurnish and get reopened. So they told us that the racetrack has the best internet connection. So I don't know how many webinars have come from a horse stall, but that's where we're located today. So whatever works. But
Yep. We've actually got to see the composting pile out back as well, so we're in good shape here and good company. So we're good to go. We're glad everybody joined us, and thank you all for logging on this afternoon.
You bet. So just to get started, first of all, we are recording this session, so it will be on our website or in our toolkit. And as we've done with the last couple of roundtables, when we get done with the Q&As, we send some stuff back out to our presenters, and we actually put together an FAQ document to go into our toolkit to be alongside of the recording. So we try to make it as good of a resource as possible. The other thing before we jump into it is you will be getting a survey after the webinar, and it's only two questions. Number one, what did you think of the webinar? How can we improve it? And then number two, what are some topics that you would like to have us cover in future sessions? So with that, I'm going to give just a quick overview here, and then we'll launch on. But this is really why this topic is so critically important to us. Is if you look, the U.S. Department of Agriculture every day puts out a what they call their drop report. And let's see, there we go. And so this was like last Thursday. And if you take a look, this report showed that the value of the drop, the hides and all of the byproducts, was about 1856 a hundredweight. Now, if you've got an 881-pound carcass, which USDA was using as their reference, that's about $163 and a half of value that you would be getting for that carcass. Well, that's the value that you're going to get if you're JBS or XL or one of the big packers. It's a bit of a different story if you're a small processor. If you take a look at it, there's that 163.51 value, but the small processor, what they're paying to process or dispose of a hide, somewhere maybe in the area of $4 an animal. To dispose of the rest of the offal, $10. Chris, likes to remind us that may be a very conservative figure. There's others that are paying much more than that. Well, when you think about that and then start to put it into context, that's a $177 difference between what the large processors are getting and what the small processors are essentially having to pay or leaving on the table. And if you're a small processor doing 10 head a day, that's about 25 head a year. That comes up to almost close, just south of $500,000. And so that's why we're focusing so much attention on byproduct utilization. We had a roundtable a few weeks ago on hides and leather. And now we're going to talk about composting and biodigestion. So before I introduce the folks, Chris, anything else you want to add before we jump into it?
No, Dave and I have worked a lot on this the last couple of years. We continue to focus on this. We've seen a lot of things change in the rendering markets and in the hide markets. We know you have too, as small processors. It's hitting your bottom line. We've got some experts here on the panel today that can really help show you some options and alternatives of what we can be doing with that product and keeping out of the landfills. We all hate to throw product away or waste product, but we also hate to continue adding to our landfills and our greenhouse gas issues that you hear so much about. So please, if you have any questions, reach out, send them in the chat, send them in our links. And if we don't get to all of them, please send us emails. We will get you answers to your questions. And these folks are here to help. They volunteered their time here today and then want to share the information and the success stories that they have already. So this is not a new thing for a lot of these folks that we have on the panel. This is something that's real and something that can be done today. So please reach out, ask us questions as we go. Thank you.
Yep. And as we go along, be sure and type your questions into the Q&A. And then when we get done with the presentations, we're going to tackle as many as we can before the end of the hour. Like I said, we'll get written responses to the others. So we have 3 different areas that we're going to cover. First of all, we've got Tommy Bass from the Montana State University, an extension specialist there that's done a lot of work in composting. Secondly, we've got Chandler and Adam from Advanced Composting Solutions. They're based down in North Carolina, but I think both of them are elsewhere right now. But they're doing some really good work. They've done a lot of work through the years on composting for live animal facilities, particularly chicken operations and hog operations, and now are working with us to develop this technology or to right size this technology for smaller meat plants. And then Patrick Robinette, who I've known for many years from North Carolina, and Jerry Keogh, he's from the eastern part of North Carolina. I guess it's so far east, it's called Ireland. They're with the Green Star Group and are doing some really exciting stuff with biodigestion. So we're going to have Tommy and then Patrick and Chandler present some information. And then when we get into the Q&A, everybody will jump in with some information on that. So Tommy, I'm going to turn it over to you. So take it on.
Thanks so much. I just get my slides up just briefly. All right. Well, good afternoon, everybody. I'm going to start with maybe the least sophisticated option here, and we'll talk about when it may apply, and then we'll get to hear from the other panelists with some really cool advanced ideas and maybe finding more niches when this sort of basic intro composting concept doesn't apply to the business or enterprise. So let's see what the lag is. I'm sharing. Let's advance. There we go. Okay, so traditional aerobic composting, just a little basic science here. It's the natural breakdown of organic wastes, and this is done by microbial action. And the metabolism of the components of the designed waste pile or windrow, when these microbes break down that material, they produce heat. And healthy benchmark heat tells us that we have a healthy farm of microorganisms in this compost structure. They require air to eat up that organic matter, if you will. So we start a compost pile or a windrow, which you can think of a windrow perhaps as just a longitudinal pile, with a coarse base, and thinking about whether it's routine mortalities, disaster mortalities, or food processing waste, meat in this case. We'll probably have about an 18 to 24 inch base of coarser carbon material, 2 to 4 inch shredded material with some fines, or playground chips. That's what I like, because it's versatile throughout the pile. Playground chips are what we see out at the city park under the swing set and whatnot. And they often have 1 to 2 centimeter chips, which give good structure, and then some fines, which is sort of like the fire starter to this microbial population. So you put that base down, and then comes your waste. and you can balance some additional carbon with that waste going on top of your base or your pad. Some issues there to think about is moisture management. And that's just another fine-tuning thing you would play with on moisture versus carbon versus the protein-based nitrogenous waste. And then, so you can think about that layer being another 1 or 2 feet. And then you're going to come back with some sort of light, clean cap. Different thicknesses are site dependent. It might be some finished compost that you have on site, maybe some coarse sawdust. Once again, these versatile playground chips, they're kind of, for me at least, they're a quiver of one sort of carbon source when you're dealing with waste like this. So what you end up with is, you can just imagine a pile like this. Maybe we have a couple layers. These microbes go to work within hours. We can see temperatures up to 140, 150 degrees Fahrenheit within 24 hours of building a pile like this. There's, a lot of internal dynamics happening, moistures changing and temperatures. But basically, we find when a pile is built well, and the sort of on-site trial and error and art and science is figured out, this can be a low odor, pretty quick process. It doesn't apply to all situations, and we'll kind of get into that in a moment. This type of basic aerobic outdoor composting is probably most ideal for a rural plant or a plant that has some sort of, generous free outdoor space adjacent to the site, or a short commute to an offsite location. And finally, in any of these situations, whether rural, on the edge of an industrial area, or even, nearby offsite, if you have neighbors that might, find contention in this situation, it might not apply. And I think some of the other presenters are going to share with you some ideas where we start, dialing in. If you have a plant that is in an urban area, or, you have more neighbor issues. And, I said this is low odor and sometimes no odor, but you're still handling sensitive materials. It doesn't take more than an hour or so before maybe the buckets or totes of material that, you're moving out of the plant and into the compost area start to have their own odor. But just to move along a little more quickly, you want to have an area in that base, that 18 to 24 inch base, really prepared for the full week's need. And then, on the slaughter harvest days, you can bring that waste out, mix a little core material, a little bit of clean cap, and then, move on down that week-long prepared base throughout that week of harvest days. You can place this manually or by a loader. Need to have your other supplies stockpiled nearby. So that's the extra carbon, a little bit of core mix, clean cap material. Want to cover everything quickly to keep that odor down. We can see 3 to 6 week processing on this. So you also have to have a certain amount of space to deal with that lag time. You can speed that with turning. Some issues that can influence time to completion and just learning your process are the carbon material to waste or nitrogen material balance, the amount of moisture. You can apply blood to these piles. Then you'll need to play more with carbon because of that added moisture. But I'll tell you, this can be feasible anywhere from the Virgin Islands to Montana. And, we will see core temperatures, 130, 140 degrees, while it is single digits or below zero outside. We have had dusting of snow across the top of a pile and 130 degree core temperature in that pile. Just to give you a little bit of reference point, this is some statistics on really just some space and material estimates on what you would need to do. So say a plant doing 20 to 25 head per week, looking at say 1,000 pound basis as opposed to the 800-pound basis and those intro drop statistics. You know, per animal unit, about 5 yards of base. I'm talking about cubic yards, about another 5 of core, optional 4-inch cap, 1.5 yards. And then that footprint is going to be 7 to 8 feet wide, and 6 to 10 feet, or long or wide, doesn't matter really, but we're going to see a width of the pile or windrow 6 to 10 feet, get sort of a pyramid deal going. That 1,000 pounds of waste will occupy, you know, the other dimension, 6, 7, 8 feet. And let's see, for a recent project, we estimated for that 20 to 25 head per week, that we would recommend 1/3 to 1/2 acre for working and having active windrows. Okay. And then another 1/3 of an acre for carbon stockpiling, those other materials, curing space for, say, a finished windrow. It was all mixed up and you just set it aside to cure before you might market it, move it to land application, soil amendments, loader parking, some other just, you know, storage space. You know, so in the end, for this sort of facility, a 20 to 25 head per week on a animal unit basis, 1,000 pounds, 2/3 to 1 acre would give you a lot of space to run everything you need, turning radius and gaps between active windrows, storage space, etc. So as you see, this is not going to apply to the compact plant in an urban area or without much yard space, so to speak. So with that, that might have sparked some questions. I could have also misspoken, and I can go back and correct myself, but I will pass it on and look forward to circling back to you during the Q&A.
Great, great. And then I'm going to turn it over to Chandler and Adam, but just as a point of reference, I met these gentlemen in January at the International Processing and Production Exposition down in Atlanta, and was just fascinated by the work that they're doing. So pleased to have you guys here. So Chandler, go ahead.
Well, first of all, thank you for having us here. And Adam's going to be my screen share for me and pull up our little slideshow for you. But ACT, or Advanced Composting Technologies, we've been building facilities, manufacturing equipment for composting for about 25, 26 years now. We've built over 450 systems across the US, Canada, and even recently down in Peru, the Caribbean a little bit. We've got a second business that we do a little bit of consulting work during disease outbreak for the high path avian influenza, and some training around the foot and mouth, as well as like the new African swine fever that people are kind of looking at from a distance, hopefully. Working with those facilities, we do over 100,000 tons of mortality waste currently per year. That's all the facilities kind of added up. We're growing at about 10 to 15% per year, so we're adding quite a bit of tonnage to that every year. And that doesn't even start to talk about the amount of volume that we deal with on the consulting basis. Our facilities, we use pre-processing. If you look at that top picture to your left there, that's one of our pre-processing units. We're going to stay on this slide for a little bit, Adam. That is where you can control the diet. We've got different styles of machines for different processes. Of our 450 facilities, there's about 90% that is daily animal mortality. Out of that rest of the 10%, there's probably 5% that is actually processing plants. We only started getting calls from processing plants when COVID hit. All of a sudden, there was some USDA money out there for the smaller plants, and they needed to take care of waste. We built some that are feather and some that are on hoof and off hoof. We've got facilities right now that are dealing with 40,000 pounds per day. Or no, I'm sorry, he's 40,000 pounds per week. I've got some little notes over here I'm cheating from. And then up to 200,000 pounds per day. So we've got some that are starting to have a little bit of volume. Our small facilities for daily mortality, we're anywhere from 100,000 pounds annually up through about 5 million pounds annually. We've got industrial waste that goes up well above 90,000 pounds annually. So we've got big to small, I guess is what I'm trying to say. In doing the multiple facilities, the different animal types, and even in the processing stage, we've learned that feathers can be as difficult as hide. You know, you've got issues with both. You've got issues with the more calcified bone of the older dairy cows versus the steers that you're processing. So there's difficulties in all of it, but we like to innovate, that such as our pre-processing. That's nothing but a total ration mixer that we wanted it to grind as well as capture the liquids and to control diet. The TMR mixer, they weren't beefy enough to really get it done, so we beefed them up. We added horsepower and torque, and to do that, you added frame. We added a lot of cutting and knives that doesn't make the unit a great mixer anymore, but it makes it a great pre-processor, meaning we want to capture the liquids. We want to make those, when we're dealing with whole animals, we want to break them down. The bones, we want to bust them up. If we can open a bone when it's still a living tissue and it has marrow and blood inside of it, the microbe can get in it and break that bone down. So that's the idea of the pre-processing. Control the liquids, control your diet. You're following a scale, so it's easy. We add hammer mills to that unit to break down bones further, both on pre-side and on post side. It's a different option, so we offer options. We'll talk about in the questions and reviews, ask me about our issues with hides, because we have found that there's some problems there. Until you just throw it into the hot compost, it just goes away. But again, just to be a little bit on the shorter side, we like to build our facilities under roof, mainly because we can control what the rain's doing. We can also control the sun. You know, if we can keep it under shade, you know, we can control that moisture a little bit better, as well as controlling the rain. You know, you want to stay at a 45% moisture roughly to get it actively composting. Once it's curing, you want it to dry almost to a 30% moisture before you spread. That's a good spreading moisture. You can go to the next slide. Our basic process is simple. We pre-process different style units for different product, but you can go to that second slide. That's great. We loaded in that dry paper towel. The carbon's loaded first. We're using everything from corn stover, peanut hulls, sawdust, you name the gamut. We've gone all the way for our carbon sources. We change the knives out, not only for our product that we're loading, the calcified of the bone, as well as the size of the animal, or the offal and bones and the stuff coming from the butcher shop. But the process is the same. You load your dry first, you load your wet waste second, you mix it up. It comes out in about 15 to 20 minutes in a, you know, most of your bones are broke down in the first 20 minutes, about 80% are broke down. Then the compost goes to work on it. Microbes can eat that calcium as long as it has living, it's a living bone. Once a bone becomes white, all the goodies are gone. So that's why they just stay around forever. They're basically a rock. So get it on air is the way we like to do it. We'd like to do it on the roof, but we've sold these units both to row facilities where we're pre-processing to put it in windrow, like Tommy was saying. The benefits of air and pre-processing, that same size bin that Tommy was talking about a minute ago, the 8x10, he's putting about 1,000 pounds of wet waste in there. We're doing about 10 times that in that same area. That's your reduction of size that helps to pay for the technology. You can go to the next slide. I'm going to run through the system one more time. Step one, we're going to load the preprocessor. Step two, you grind it up, convey it out the conveyor to the dump bin. Step three, you scoop it up, you put it over on the first stage floor, or you're scooping it up and you're building it into a windrow like Tommy was describing earlier, except it's already a homogeneous material. The diet's right, so you're not layering it and covering it, layering it and covering it. You have a layer that you still have your filter on the floor or the filter on the outside to create your airflow. You load your body and then you cap it. Then you go into a curing phase, meaning you don't want to put 160-degree material, and we will get up to 160 degrees about day 3. We're usually 150 in the first 24 hours with pre-processing and air. You want to hold temperatures for at least 5 consecutive days above 131. With our systems, we like to be above 150 for at least 10 days. About day 11 or 12, it starts to cool back down about 5 degrees per day because everything's gone. It's eaten up. Large animals to small, processed or on hoof, they're still gone after about 14 days. At that point, you've got a great finished product. You know, it's a good fertilizer. It's 1917. It's good to put on the fields. It's sustainable for the land, and it's sustainable for your pocketbook, meaning we kind of try to reduce that footprint to make a lot less labor to build it. How much does it cost? That's always a question. And we'll get into that in a little bit more detail. But again, of the ones that we've got for processing, our 40,000 pounds per week guy had a lot of options that he added to his. He's $550,000. My 200,000 per day, he's a windrow unit. All he's got is our preprocessor for that size system. He's about $150,000. So it really depends on, you know, what you want, how turnkey, how many options. There's always options like buying your car. You know, you want leather seats and air conditioner, or roll down your window and bucket seats, so to speak. But that's who we are. We love composting. We love consulting, and I always offer my time, and I'll offer Adam's. You know, if you've got questions, we're here, and we're here for the past 25 years, and we're hoping to be here for 25 more. So give us a call. We'll help as much as we can.
Great. I really appreciate that, Chandler. And now, yeah, we're going to switch gears just a little bit and talk about anaerobic biodigestion. And Patrick, I'll turn it over to you, and you can tell folks if they aren't familiar with that, what that is.
Yes, sir. Thank you a lot. Pull up my presentation. So thank you for the opportunity to speak to your group here. My name is Patrick Robinette. I'm with Green Star Group. And I need to be remiss to say that we're not composters, we're digesters. And I have the experience that a lot of y'all have had in that I'm a cattle producer, but also a processor. And I was struggling for decades to find an answer for our for the offal waste. And we joined forces with HARP in their technology. So we're a U.S. company that formed in 2023, and we're affiliated with HARP, who is the manufacturer of the thermophilic aerobic digester. And right quick, the process is you load the material in and then you walk away and let the machine do all the work. Process completes in 24 hours. There's environmental and waste reporting. It gets to 160 degrees, and then, so all pathogens are dead, has the lowest emissions, and it sequesters the most carbon and retains most nutrients. Material coming out of meat processing facilities would be classed as a fertilizer, and this is one example that we have ours classed out of Ohio, and then we're getting it classed out of several different states as the units are going in different states, and we will get the work done to get it classed. So it's not being sold as a soil amendment, but as an actual fertilizer. And the deal is with us, it's everything. It is the blood, bone, hides, heads, meat scraps, everything. There's a techniques and just like the folks with Advance said, we put in systems to handle all the facets that you are struggling with. But again, digests the waste in 24 hours. Our footprint, 500 pounds a day, is on as small as a 6 foot by 10 foot area, all the way up to 10 tons a day is on a 28 foot by 50 foot area. So we're the most compact option. And as Mr. Tommy was explaining, if you're in a rural area, or excuse me, in an urban area where you don't have a lot of area to be able to do composting, this is a solution for you. Also, if you just want to deal with the material and be done with it, this is a solution for you, because you're putting it in. It's fully automated. Computers take over, and then it does all the process, all the turning, the removal of the moisture, heating up, and then unloading. And all you gotta do is have the bag sitting at the end, or the tote at the end, capture the material. We use our own microbes in the process. There's no needed for any additional carbon source. Again, you're dumping the material straight in the machine, and then the machine takes care of the rest. Our process kills the odor in the machine immediately. It's very stable and pasteurized. We tailor the machinery and the support equipment to your needs. So, like, for example, if you have if you're moving the material in 55-gallon barrels, like a lot of places are, we have a bin lifter. You just roll the bin up on the lifter, dump it in. And all the way to, like, my facility had conveyor belts, and we put in a conveyor belt. So in our situation, the inspector did the inspection of the digestive tracts and repo tracts, everything on a table, and then the table rolled over and then just pushed right off. So, like in my situation, using the conveyors, I was able to minimize the handling, the number of times of handling. But we tailor the machines to your operation. We can fit it around to your to your footprint and your abilities to house it. Feed system is designed for the individual plant, and then the machinery is a full stainless steel. The longevity runs about 15 years on the equipment, and so this is a process that we found that you make the investment and it's around for a while. And so the only difference with us is that our system does require electricity. So we would work with you on your facility and see your needs or see what you have and then talk to you about needs. But that is, that's the short and sweet of it.
Yeah, and Patrick, yeah, Chris was just mentioning you are an active processor right now. In
Correct.
addition to being a rancher and that, so you got to go the full gamut. I appreciate that.
Right.
So
I
we're
was
gonna,
able to put my hands, like be involved and my facility is in an urban area, do have a limited amount of land, available. And so this was a solution that I found that worked for us.
right. So we've got some questions here, and folks, if you've got some, type them in there. We'll get to as many as we can. So Sherry's with us from Indiana. Sherry, I'm going to tackle both of yours. You got them here, but for Tommy, it says, is the pile on a specific pad such as concrete? Is there any concern for rain and runoff from the pile? And is this per animal, cattle, hogs, or both? And then she adds, is there a volume break point where it does not make sense to compost?
All right. So Sherry, I'm looking at the first part of that. We've done this on concrete. We've done it on a compacted clay surface or compacted rock substrate aggregate of some sort. And then how that relates back to the water quality aspect is, of course, you would want to divert any run-on water or storm water from that site. So guttered roofs anywhere around, that might put stormwater into your composting area, berms, ditches, or swales to keep runoff, out of that compost area. A lot of times, and in many environments, of course, in humid and high rainfall areas, this wouldn't apply. But for much of the United States, we need a bit of that environmental water to keep the process going. And in the arid West, for example, I know you're in Indiana, it sounds like, sometimes we might even take that cap of the compost windrow and furrow it a little bit so that we can capture some environmental moisture. But that's in our arid climates. The right balance of carbon and whatnot, you can do this successfully outside and manage the stormwater. As far as any leachate coming off, once again, we could play with carbon, but it is still perhaps in your environment an advisable BMP to have a grass filter strip or a little sediment basin or some sort of capture area for any runoff that could leave from the composting facility. Those statistics that I shared on the little case study was first for 1,000 pounds of waste. So if we are thinking about what would that mean with a finished steer, that'd be like 2.5 steers worth of waste for that 1,000 pounds of waste. If you were thinking about composting and mortality on farm or ranch, that 1,000 pounds of waste would just be the whole intact animal. So I will stop there and maybe I'll let someone else jump in on that financial breakpoint where, hey, we've got an operation large enough, might not be in the small to mid scale anymore, where rendering could become an option again, or scaling up some of the technologies these two gentlemen after me talked about. So I'll pass the torch.
Yeah, Patrick or Chandler or Adam?
I'll go for it. I mean, as far as scaling up, if you've got a source for fertilizer, meaning if there's row croppers around, they want fertilizer. In the Midwest, fertilizers going, or compost fertilizers going from anywhere from $90 to $180 per cubic yard. A cubic yard weighs about 750 pounds. So you can do that by the tonnage. As far as in areas where you don't have a lot of nurseries or sod farms or anything like that wants compost, then you might want to look at rendering. And as well as rendering might be a closer to where your processing is. Rendering is depends on if the renderer wants it or not, right? When they want it, it's great, and when they don't, it's really bad, right? So scaling up, amen, go man.
You don't
Yeah.
want it, Chris and I, to get started on the rendering industry
We'll,
right now.
we'll let Patrick, we'll let him go off.
Yeah,
on that.
Patrick
Yeah.
can run with that one.
Yeah, go
And
ahead,
it's the most
Patty.
it's the most liberating day when you call Valley Protein or Darling and tell them to go get their freaking barrels and you don't want to see them again. Hey, in our process, you're running out about a 60 or 70% yield. So 1,000 pounds in, we yield out about 600 to 700 pounds of end material. We're seeing values of between $400 to $900 per ton is the value of the end product, and it is, and as I say, it's classed as a fertilizer. And for us, so you can start out. Our systems is modular. So if you're at a certain, I don't want to look at capacity. I want to look at your historic slaughter schedules, and then take and put in a equipment that meets those needs. Then from there, if you grow your capacity, we can slide equipment right on in, right beside, and so it's a plug and play situation. So that's we can expand out and grow as you grow with your process.
Great. And then next set of questions, and I am not even going to try and tackle the pronunciation of your name here. It's rather complex, but you say, I'm a PhD student and this is my first year. I try to transform waste, tomato, olive pumice, poultry manure by forced aerated composting. Can you give me some advice, please? And then following up is for all of you, are there any microbes alive in your compost when you're finished?
Let's see if
I'll-
you don't. Oh,
go
pardon
ahead,
me.
No, you're great.
I'll leave my email address in the chat, and on that first question, we can just start to make some referrals around. And it sounds like you're maybe more interested in smaller footprint forced air composting, which is great. On the second issue, yeah, we find that the finished material is pretty sterile and safely sterile. You know, a lot of those temperatures that get generated, even though the compost microbes can be thermophilic, they use up all the nutrients and materials of their life as well. And then with those high temperatures, you're reducing and destructing pathogens. But then a certain amount of that answer is also, it depends. And I'll pass the mic.
So I'm going to go back through your products, if that's okay. Tomatoes, olive, pumice, poultry manure. Sounds like you've got some good, both dry and wet there. You're a little bit on the heavy on the nitrogen side, so you want a little bit more carbon. In composting, your carbon is your energy. It's kind of like fire in the fireplace. You know, you want to keep stoking the fresh wood in there to keep the fire burning, so to speak. Once it's just coals, you're more towards just the nitrogen. It'll keep going for a while, and then eventually those coals kind of start to smolder and die out, and you've got to rebuild it all the way back up with fresh carbon every time. So a good happy medium is what I always try to preach. But you know, 25-1 to 35-1 is the lowest you want to be on the carbon to nitrogen ratio. As happy as you can get, 45-1 would be great, but it can be very expensive for carbon as your one costly piece of composting. So I always try to look for free carbon sources, and there's always free carbon because people are throwing away cardboard and throwing away all kinds of carbon every day. Live microbes, absolutely. And nature is your best microbe source, meaning when your microbes allocate or get, what's the word I'm looking for, Adam? It's one of my favorite words. When they get used to the diet and the environment that you're feeding them in that home,
Acclimated.
thank you. When they get acclimated to that diet in the home, they get stronger and your colony continues to get stronger. So repitching your hot compost or your microbes back into the system is just always a healthy way to keep that cycle of life growing and getting stronger for you. So yes, they are alive and active and happy and hungry. And as Tommy and Patrick and Adam will say, we'll all share our contacts so that you can reach out.
Yeah, and just as a point of information, both Green Star and Advanced Composting Systems have some information on their systems in our online toolkit. So, but we'll make sure everybody gets that. So we had an anonymous person here saying, can you talk a little bit more about what comes out of the biodigester? What are the uses, the amounts, etc.? Patrick and Jerry, that's yours.
Yeah,
Gary.
I'll answer that. So basically, what comes out of the biodigester is exactly the same as what goes into it, only it's the it has been reduced, the moisture has been taken out, and it has been digested. So what you get out is like a spent coffee, with no odor. It's like a powder, a dry powder. Now it depends. With some animals, it can come out a little bit more greasy. It depends on the fat content. So what we do is we tend to look at what the machine has been fed, and then we can change and we can program to suit them needs. But in general, it's like a spent coffee.
All right, great. And I see Catherine from Maine had a question. She said it was a little loud when we started, so she missed some of the information. But Patrick, I see that you are typing in that for her as well. So I'm going to jump over Catherine, who we were just with in Puerto Rico, at the University of Puerto Rico on Monday. Glad you can join us. But she said, would you be able to share a ballpark cost for the composting mixer?
Absolutely. We've got pre-processing mixers that start at 10 horsepower and go up to 200 horsepower. Plus we got PTO units. The 10 horsepower starts around 40 plus shipping and install. You know, your really big units, industrial size units go up to $250,000. So it's a pretty big window. But most of our facilities, you know, the 10, 20, and 30 horsepower takes care of it, and that's between 40 and 65,000. Let's just say your bigger bones, I would still use a smaller unit and a hammer mill until I get to a lot of volume, and a lot of volume is towards over 30,000 pounds per day. So it just kind of depends on where you are, size wise. Catherine, I know that that's real broad, so send me a question that on your exact volumes, and I can type, and I can give you exact unit that I would suggest for you.
Great.
I'm just following up on those mixers. The work that I've been a part of recently, looking at whole animal carcass grinding for disaster composting, when you can mix whether it's offal and plant waste or if it's it is amazing to see the bump in performance when you break up those carcass or waste components, mix it with that good core material carbon source, and then get it either onto the aerated bins, out on a windrow. It's amazing. And it is, yeah, it's that next big step from the very basics that we led off with today. It's quite impressive.
Anybody else? All right. Donna is in North Carolina, and she says, Patrick, can you share the location of where your unit is if somebody wants to come by and see it? And I would ask the same for Chandler, because I know you guys have got maybe some smaller processors you're working with. And Tommy, you can tell folks where you're have some projects up there in Montana. So,
Yep. Yeah, I'm been messaging Miss Donna, but yeah, we we can we have a unit in Montana. I'm up in New York right now with a unit, so we're all over the place.
So if somebody contacts you, there's a good chance you might have something sort of in quote their neighborhood unquote. They might be able to take a look at. Yeah.
Correct.
Great. Chandler, but how about Chandler and Adam? I know you talked about a couple that you're working with.
Absolutely. We'd love to give addresses. North Carolina and Pennsylvania are where the processing plants that we've got right now. As far as compost facilities, we've got them in a lot of different states. So tell me where you're at, and if you're in North Carolina, I mean, tell me what county or city you're in, and I can put you right on top of somebody pretty quick. So yeah, I would love to share, and we've got a ton of them out there. Just kind of let us know. There's some that the biosecurity, meaning that the live animal production, especially our sow farms, they don't like a lot of traffic, but we've got some farms that we can put you on too. But
right.
our processing plants, just let me know where you're at, and we'll go from there.
Yep. Tommy?
Yeah, we've got a few floating around. And same with either some are processor and ranch partnerships, some just on at or near the processor. Just with client confidentiality and privacy, just reach out if you're going to be in the area or if any of our audience is curious, and then we'll start to try and make some introductions and see if you could see somebody's place.
Great. And Chris just said we have a question. We have a studio audience here today. We got a couple of folks sitting next to us. So go ahead, Chris. Just
Live question from Virgin Islands for Patrick here. Patrick, the product coming out of your biodigester, what are the common uses for that product when it's coming out?
So there's two uses. Jerry's about to stroke on me. So the first usage is as a fertilizer. And then the second use is then with the collection of a certain volume, we can then run the material in through an anaerobic and extract out energy.
So is that running through heat exchangers and being maybe burned or used up in that method? Okay.
That same for Chandler's. That same for Chandler's.
And Chandler, is that the same for your system, or do you see yours more field applied?
So for our systems, I mean, you've got just a compost that's ready to be field applied, leaving the site. And, we do have some large facilities that are bagging and selling at your garden store, so to speak.
Gotcha. Thank you.
Yep.
Jerry, do you want to answer the anaerobic side?
Yeah, I think one of the key things from our end product is that because we've captured the CO2 and the methane, it has a very high calorific value. The calorific value is about the same as wood. And what we have done in Europe is we put it through an anaerobic digestion, and we've extracted the energy to generate electricity from it.
All right.
We've used it as a fuel.
Yep. So a question here, somebody's up on in Washington State on Whidbey Island. They're saying, is there anything on the West Coast that they could connect with?
To look at for
To look at one of your systems, yep.
Yeah, we have some in California, not at meat, but they can see the system working. It works exactly the same. We've got California, Montana, yeah, Northern California, I think Sacramento, probably be the nearest.
Right.
And
And
Canada.
then, okay. And then trying to wrap up because we're coming up to time here, but Sarah wants to know how hard it is to clean and service the grinder for the advanced composter and the whole system for the digester.
So on the preprocessor for our system, it is kind of self-cleaning, meaning you empty one load, you throw in the paper towel or the carbon, and you're ready for your next load. But that is, you run it for about 30 seconds and it kind of self cleans up anything that was left in there. If you're going from site to site, as with any equipment, you would empty it clean and then spray it with either steam or you know, the sanitizers for a biological standpoint if you're working an active disease or that type of thing. But daily, you're cleaning out every time you empty it and move it over to active composting.
Great.
Yeah.
So I'm going to try and
You-
get to three more questions here, but one of them is where can a small processor get an affordable hammer mill to break up the femur bones, etc.?
That's part of our cost. And when we quote a cost of the system, it's all part of that cost.
Okay. Chandler, any thoughts on that, or does your grinder take care of it all?
We've got some hammer mills, and I've got small bone hammers that are real slow, that start at $7,000 and go up from there, I guess. And they handle about, what is it? I think it's 1,000 pounds per hour. You know, is the small one. They're about a 1/4 by 1/4 inch chunk that comes out, and they are manufactured by others. I'd just give you the contact.
Great. And then there was also, where in Pennsylvania, North Carolina, can we visit either of these? What I'll do is I'll let you can contact these folks offline and arrange for it. I think they're kind of hesitant to say, hey, come on out to here and have people just showing up. So, for biosecurity and everything else. And then the final one, which is a question I think a lot of folks have, are grants available to help get going. And right now, we're kind of in a lull in terms of the grants that are out there for processing. I know a number of folks that are probably on this session have got applications in for MCAP or MPEP and are waiting to hear. And all we can tell you is we're all still waiting on those. So just be patient. And then I guess we got music here kind of tuning us off. Yeah, it's sort of like the Oscars as the time is up. But I would just say that we're all looking at the Farm Bill to see what will be happening with the Farm Bill when it comes about. We have been talking to USDA that as there's more money for helping smaller meat and poultry processors, they've got to put attention on what comes off of the slaughter floor and not just out of the drip coolers. So please stay tuned. We can't lobby for the Farm Bill, but we're watching eagerly to see what the folks that are writing the Farm Bill, and those of you that have that need, certainly feel free to contact your representatives and senators as well. So
I would also add too, to watch your state departments of agriculture. There are some grants coming out that are supporting meat processing facilities as well as other food processing facilities in your states. So watch the state departments of agriculture for new grants coming out through the states as well.
So anything else you want to add, Chris?
No, I appreciate all the attendees and all of our presenters. We thank you all for attending and appreciate all the valuable information. If we did not get to your question, please email Dave or I, And we'll make sure and get you connected to one of the presenters if you didn't capture their email address already.
And like I say, we're going to be putting together a sort of a FAQ document based on these questions with a little more expanded information that'll be on our website. So any of the presenters, anything else that we left uncovered here?
Well,
good.
I think,
Thank you, guys.
yeah, I think we're good. There's a lot
All
uncovered,
right.
I reckon, but I'd be glad to
Okay.
follow up if anyone wants.
We'll cover it up. It's a burning topic. So, all right, folks, thank you very much for being with us today. And
Thank you.
have a good day.
Thank you.
Thanks, guys.
Bye. Bye-bye.